Happy day. I am Dr. Padmasini, Department of Information Technology, M.O.P. Vaishnav College. I am going to give a brief introduction about R programming. R programming was created by Ross and Robert Gentleman in the year 1993, and currently it is developed by R development team. R is an open source programming language and it gives a software environment, and it is used for statistical analysis, data visualization and machine learning predictions. So R is an interpreted computer language which allows branching, looping as well as the user defined functions also. R gives the effective data handling facilities and storage facilities. So let us discuss about the features of R programming. So it is categorized into 5 major divisions. The first one is versatile data structures, statistical analysis, extensive libraries, data visualization and data cleaning. Versatile data structures refers to different set of data structures which is available in R programming, which is going to facilitate different set of data that can be stored and it can be retrieved, which can be used for statistical analysis. Next one is statistical analysis, which gives, for example, we want to calculate mean, median, standard deviation and other statistical analysis. So we have lot of built-in functions to enable them. The third one is data visualization. The output or the report whatever we want to generate, it can be visualized using plots, graphs and charts. Data cleaning. So data cleaning and pre-processing is very important for the data analysis. So pre-processing and cleaning can be done using lot of built-in functions. For example, remove, fill, these are all the famous data cleaning options which is available. Next one is extensive libraries. So we have lot of packages and libraries which can be inherited in R programming to facilitate the built-in functions. So R Studio is a tool to work with R programming language, which is very easy for analysis to import, access, transform, explore and plot the data whatever we are going to analyze and to make predictions very easily. So in R Studio we can create n number of new files which is available at the top of the window. Down we can find out the console which is going to give the output. Right hand side is the environment where the variables whatever we are going to create which is going to be exhibited. So we will have a brief discussion on the data types which is available in R programming. They are vectors, list, matrix, arrays, factors and data frames. So before moving into the data types, we should know what is the new feature which is available into the assignments. See, normally in any programming language, whenever we want to create a variable and we can set out a value to a variable, just we will have equal to. But in R, we have another 2 different operators to represent the assignment of the values to the variable. So we have 3 different combinations of the assignment variable. First one is equal to, we can find out here. So variable 1, we can assign the data into using equal to operator. The next one is the leftmost operator where the variables can be assigned to a variable. Next one is the rightward operator where we have the values is being navigated to the variable. So 3 different operators is used for the assignment. The first data type is the vector. So vector we can have atomic vectors also where a single value is going to be stored into the variable. Apart from this, suppose I want to have more number of values into a single variable, that can be possible by using C function. C stands for combine. So whenever we want to have more than one value, it can be given as a combined function and it can be stored into a variable. So a vector is a items that is of the similar type. I can store integers, I can store characters, but it should be of a similar type. The next data type is the list. So list is a generic object consisting of the ordered collection of objects. This is a heterogeneous data structure. It is one dimensional. So heterogeneous refers to I can have different set of data types, for example numbers, strings. I want to have one more list into another list, nested list. All this is possible in list. Okay, so I can have list of different types such as numbers, strings, list, matrix. So anything whatever I want to, I can just combine into a data structure. So whenever we want to create a list, we want to merge it, so we can implement using merge option. Suppose I want to convert a list to a vector, even that is possible using unlist function. The next data type is matrix. So matrix, we all know it is a two-dimensional data structure which is a combination of rows and columns. So a column is a vertical representation, so whatever data we want to represent in the column, that can be done, and the row we can have the horizontal representation which is going to represent as a record. So by easy way we can create a matrix where we are going to give the data, followed by we can represent how many rows we want to give, how many columns we want to give. All those things we have attributes as the option while creating the matrix. In matrix, suppose we want to arrange accordingly to the row wise combination. I want to arrange sequentially according to column wise. For all those things we have options. The next set of data type is the factor, which is very much used in categorical variables or categorical values. Suppose I want to make out a data analysis where I will have a set of values that is going to be repeated. For example, customer satisfaction report, I will have better option, I will have average, I will have excellent reviews on the customer options. So I will have only 3 set of values which is going to be represented as a factors. So in that case, these categories or the factors which is going to be very, very useful. So I can generate what are all the categories that is going to be represented, that it is going to be given as the factors. So this we can combine it for analysis. The last one is the data frames. So data frame is a tabular data structure which is going to store the values. So here I can create a data frame using different set of columns. For example, according to this example, it is given as employee ID, where I can have 1 to 5 as the values. Next, employee name, I will have a set of values. Then what is the salary and what is the start date in the employee organization. For all those things, I am giving a set of values where the data is going to be created. So the output of the data frame, you can find it down, where you will have employee ID, employee name, salary and the start date. So this is a tabular data structure. Whenever we want to pull data from a different, for example, CSV or Excel, I want to pull it to R for analysis, for predictions, for clustering, whatever the case may be. So whatever data that comes in, it is going to be converted to a data frame and we can do whatever analysis we want it. To find out, to extract the data from Excel or CSV file or JSON file or XML, any web data, so we have to pull it from any outsourced structure to the R programming. For that we should know what is the working directory. So to find out what is the working directory, we can use the function as get WD. WD stands for working directory. Then you can make out a set WD, that is which is the working directory we want to set out, so that we can make it. And whenever we want to pull out a data from a CSV file, comma separated file, so we can create file in CSV format, then we can pull it to R programming for analysis, for predictions, for statistical analysis and for reporting also. So for that we have to give read.csv, which is going to take out the data from the CSV format and then bring it to R, convert to a data frame, and whatever we want it, we can make it with the data frame combination. Suppose we have a data into an Excel file. So we want to read a Excel file and then convert to a data frame, and then we have to continue for the analysis. So by default we don't have the package for Excel. So what happens, we have to first install the package. The package name is XLSX, so that we have to install it first. Then we have to check whether it has been installed. So this is a usual procedure. We have to make it for any packages that is going to be downloaded from Crayon package. Then we have to read that particular file which is available in the working directory. Automatically whatever data we have saved into the Excel, it is going to be converted to a data frame, and we can start working with the analysis and the predictions part. So I have listed out here few functions of statistical functions, that is mean, So, mean is frequently used. So, finding out the mean of a set of data which is available here. So, we can just give out a built-in function mean of x, automatically the data will be implemented. Suppose I do not have a value into this particular data. So, in that case I have facilities for removing that particular data and then finding out the mean. All these facilities are available, which is going to be very helpful for pre-processing and cleaning. The next built-in function is the median, where I want to find out a median between the set of values which is given here. So, automatically I can just give median of the data which is available. The next one is to find out the mode of the function. So, mode we do not have a specific in the latest versions we have, but the previous versions we do not have a specific function, built-in function for mode. So, we have to write an user defined function for mode for implementation. Here I have just listed out few statistical functions. We have a lot of statistical functions, standard deviation, finding out logistic regression. So, like this you have lot of statistical functions. Thank you.